Okay, our objective is to continue talking about probability. Today in particular, the multiplication counting principle, as well as something called a factorial, which I like to use that better than the counting principle. I think it saves some time. So that's another option today for solving probability problems. Yesterday was a nice introduction. So with the warm-up and homework, we're going to kind of review what we did yesterday. All right, starting with the warm-up. 1A, Adam, what'd you get? Good. Charles, 1B. Nope. 3/5. Annalise, 1C. Good. Jeremy, 1D. Good job. Okay, number 2. Now, it said to use a tree diagram, so there's actually 2 ways you could do this. Tree diagram or multiplication counting principle. So who can explain how to do the tree diagram? Annalise, what'd you do for your tree diagram? Okay, blue, pink, and white. Okay. That's okay. Okay, so how many possible outcomes were there, Annalise? It would help if I could count, right? Okay, good. So 12 possible outcomes by making your tree diagram. Now, you should still get 12 if you use the multiplication counting principle. So how do you use the counting principle here? Doug, how do you use that? Okay, good. So 3 times 4, using the multiplication counting principle, we still get 2. Or 12. Thank you. Yeah, it says to show them, but I'm okay. Someone asked if they had to draw a tree diagram. I'm okay if you don't. Okay. Okay, number 3. Sean, or question? Do you have a question? 5/8. Sure. How about 3, Sean?
I got 5.
Good. 5/26. Vowels are A, E, I, O, U. We're not going to use Y. So A, E, I, O, U, there's 5. Okay, number 4, Mary, 4A. Good. So it was 16/30, which reduces to 8/15. Perfect. Alyssa, letter B. Good. It was 10/30, which reduces to 1/3. Okay, number 5, some of you guys were a little confused with. So basically 5 says if you roll a 6-sided number cube and then flip a coin, what is the theoretical probability that the coin shows tails and the number cube shows a prime number? Justin, what'd you get? Okay, how'd you do that? Nice. Okay, that's a great way to do it. Anyone do it a different way? Okay, it's not 1/6. Annalise, the answer is 1/4. There's one answer for number 5. Matt, what'd you do? Okay. Okay. Perfect. Good. So tree diagram works. Did anyone list all the outcomes? I listed them. Listing them is the same thing as making a tree diagram. So what I did is one option you could have is heads with the number 1, heads with the number 2, etc. You could also have tails with the number 1, tails with the number 2, etc. There are a total of 12 possible outcomes. Okay. What's the favorable? So in other words, what can I circle on here? Doug, what can we circle because it's the favorable outcome? With the tails. Good. So there's 3 favorable outcomes with tails and with prime. Remember, 1 is not prime. Okay, you have 2, 3, and 5 are prime numbers. So 3 out of 12 is your favorable over total. When you simplify that, you get 1/4. Now, tree diagram would work. Mentally doing this would work. Okay, but they want to know what's the chance of getting tails and a prime number. Annalise?
So I did the answer for tails and then for prime number. Like I didn't need to
Yeah, it's one question. Probability is always going to be like that. They're going to ask you about 2 or 3 different things, but it's one answer. Nope, because you're doing it, it's the same thing. You're trying to find the probability. Rolling a number cube, flipping a coin, what are the chances you're going to get tails and a prime number? Okay? So never do it separately. Anyone else on that warm-up? Questions on any of it? Jeremy? Yep. Yep. No, because that's not what the question is. The question is not that you're going to get one number on the number cube. It's that we're going to get a prime number on a number cube. So you could do 3 over 6 times 1/2 because there's 3 prime numbers. But that's more into probability for next year. So I'm not going to get into why that works. Doug? Why would you do it that way, though? Okay. Yeah, you could. I just think it's easier for you guys to list them all. Okay, any other questions on the warm-up before we go to homework? All right, let's go to homework. Let's start with practice 6.7. Okay, then we'll go back to the other assignment. So start with practice 6.7. Okay, Sean, can you tell us what you got for number 1? Good. Briar, number 2. Good. Zach, number 3. Say that again? Nope. It should be favorable over total. Maybe you were thinking odds. Annalise, what'd you get for number 3? Good. 3/10. Charles, number 4. Good. 1/5. Number 5, Emma H. No, it's odds against. 4 over 1. Good. Doug, number 6. Good. 2 to 3. Number 7, Justin. Good. 5 times. Number 8 is 4/9. Jeremy, number 9. Good. 1/3. Number 10, Donatus. Oh, yeah, that's right. Alyssa, number 10. Good. 1/2. Matt, number 11. Good, which reduced that. Okay. Good. 3 over 2. I don't know what that is. Number 12, Mary. Good. 2/3. Number 13, Adam. Good. 16 over 45. Emma M, number 14. Good. 37 over 53. Okay. Questions on 6.7, Mary? Okay, just pick one for now. Okay. Yeah, so pick one. Okay, who can answer that? How do we know when to do overall or just parts of it? Remember from yesterday? Okay, we're going to talk about that. Zach? Unfavorable. Unfavorable. Fave. Good. So when do we use total? Zach's exactly right. When do we use the total, Briar? Yeah, whenever it's regular probability, you use total. So regular probability is always favorable over total. Odds is when you don't use the total. Odds in favor and odds against. You use, if it's odds in favor, how many of that number are there over how many of that number are there not? Odds against is the opposite. How many of that number are there not over how many of that number are there? So the only time you use total is regular probability. There's two, odds in favor and odds against. Okay? Okay, you're half right. The odds part you said is right, but if it's probability, it has nothing to do with odds. If it's probability, it's favorable over total, not odds. So regular probability is your favorable outcomes over how many total outcomes are possible. Okay? That's all in your notes if you need to go look back at it. Okay? Annalise? Okay, number 10. So Mary, this could help you if you need this. What are the odds against choosing a consonant? So this is with the word successes. So they gave us a word at the top. So for number 10, unfavorable over favorable. Okay, what are the odds against choosing a consonant? So you first want to answer how many letters are not consonants. So in other words, how many letters are vowels, Annalise? Good, 3. So there's 3 that are not consonants. How many are? 6, 1/2. Because you have them flipped. Odds against is always unfavorable over favorable.
So unfavorable would be.
How many are not consonants? Favorable is how many are consonants.
Oh,
No, odds against. Okay, and then you said 12 was the other one? Okay, 12 says you plant 48 seeds, 32 of them sprout. You need to find the probability that the next flower seed planted will sprout. So this one's just favorable over total. So all you're doing is putting 32 over 48 because that's favorable over total. It is, but they give you the data. So the number of successes, which is still your favorable, the number of successes is 32, because that's how many will sprout, over the number of trials. In other words, the total amount of seeds they planted was 48. So they gave you those numbers for experimental. Yep, just 2/3. Yep. Doug? Yes. Mary, do you need me to go over anything else? Are you sure? Okay. Anyone else on that assignment? Okay, let's go to 13.1, which was page 90. You can just go, because it's still homeroom. Okay, 13.1, let's go through these. Okay, and then we'll come back to questions. So it was page 90 in your homework packet. Okay, Emma M, number 1. Nope. I know why you put that. This one's tricky. Charles? Yeah. Charles, can you explain how you got 14? Yeah. Yeah. Right, I agree. Number 1, now Emma, yeah, this one, it's so easy. It does seem confusing. If you think about your tree diagram, 6 blue cards, 8 red cards, and you list them all out, okay, there's only going to be 14 outcomes. You don't multiply them because it's only 6 blue, 8 red. Yeah, that one's confusing. Hold on. Hello? Hi. Yeah, I do. Yes. Okay. 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 They probably did. Yes. Yes, I would say so because I have him too, and he was. Yeah, yeah. Yeah. Okay. Yeah, I think that's fine. Yeah, now do you grade by total points or do you weight your grades? Okay, then that's easier for you. My grades are weighted, so it's a little more complicated. But I think that's a great idea. Yes, yes, and yes, I think that is perfect. Okay? You're welcome, Katie. Bye-bye. Sorry, guys. Okay, anyways, for 1, 2, and 3, I suggest on those ones, especially until we get today's lesson, to make a tree diagram or to list the outcomes because it makes it much easier. Okay? Okay, so number 2, Alyssa, how many outcomes did you get? Say that again. Good, 16. Perfect. Okay, number 3, Matt, how many outcomes did you get? Good, 36. Now, tree diagrams, or you could have used multiplication counting principle in your head, depending on what you preferred. Mary? Okay, so for number 2, okay, so you roll one 4-sided number cube, okay, and you toss 2 coins. When you make your tree diagram for number 2, and number 3 is kind of like this. If you toss 2 coins, you could have tails, heads, heads, tails, heads, heads, tails, tails. You see all those options you could get? Okay, and then you roll a 4-sided number cube. Okay. That's the problem. You want to think of it as when you flip 2 coins, you're kind of doing those at the same time. Number 3, you're rolling 2 6-sided number cubes. So you make a tree diagram starting with one of them, and then you have to branch off the 6 underneath each number. I'm not going to draw all that because it's a huge tree diagram. Yep. Yeah, and I'm just not going to do all that, but yes. Yeah. Mary, do you understand that crazy tree diagram that would be there? Okay, number 4, Justin. Good. Zach, number 5. Good. Briar, number 6. Awesome. Number 7, Sean. Good. Annalise, number 8. Good. Oh, wait, no, sorry. 1 over something. It should be 1 over 2, not 1/3. So 1/2 for number 8. Number 9, Adam. It should be 7 over 2. Number 10A should be 1/4. 10B should be 13 over 60. 10C is 2/7. I could move this. 11A is 9 over 100. 11B is 37 over 50. So those are the simplified answers. If you need the answer before I simplify it, I can give that to you. Mary? That is the answer. Okay, it's odds. That's why you messed up again. It's favorable over unfavorable, not over total. You probably had it over total. So it should be 40 over 140 because it's odds, and that reduces to 2/7. Okay? Is that the only question? Okay, Alyssa? Okay, number 7. Okay, this one's tricky. So you spin a spinner 30 times, okay? It stops on a multiple of 3 5 times. So it stops on a multiple of 3 5 times. That's your favorable. What is the experimental probability of stopping on a multiple of 3? So favorable outcomes is 5 over you spin the spinner 30 times. Yeah, that is a very common mistake. You just have to read carefully and you'll be fine. So 5 over 30 reduces to 1/6. Make sense? Okay. Annalise? Okay. Number 8 says, what are the odds in favor of stopping on a multiple of 4? So favorable over unfavorable. there are 3 multiples of 4. 4, no, the spinner, there's a total of 9. There's 6 for unfavorable. So, oh yeah, 3 for favorable and then 6 for unfavorable. That's the total. You did what Mary did on that other problem. You have to have favorable over unfavorable. So 3 numbers are multiples of 4, but then there's 6 that are not multiples of 4. Okay, you're getting confused with the total versus unfavorable. Probably the same thing. Odds against, stopping on a multiple of 6 for number 9. Unfavorable over favorable. So there's 7 unfavorable. There's 2 favorable.
So unfavorable would be not.
Yep. Mm-hmm.
And favorable would be.
Yep. Okay, Doug? Okay, I already went over number 1. I know. Okay. Number 1. So blue cards, red cards. So your tree diagram, you should have blue at the top, red at the other top. There's 6 branches coming off of the blue. There's 8 branches coming off of the red. So if you count those, there's a total of 14 outcomes. You don't multiply on that one. We're going to talk more about that today. Okay, anyone else on homework? Okay, one suggestion just from the questions you guys asked, please be careful with the difference between odds and regular probability. Okay, odds in favor and odds against are very different than regular probability. Always use the total with regular probability, whether it's theoretical or experimental. Odds in favor and odds against, you don't use the total. Okay? All right, you guys okay? Okay. So a lot of you thought that was really easy, but I'm guessing you made silly mistakes. Okay. All right, let's go to our notes, 6.8, so page 21. We're just going to start this. We're not going to have time to finish it, which is fine. We're just going to start this. I'm guessing your quiz on just probability will be the middle of next week, so I should have a better idea of that tomorrow. Okay, after the probability quiz, we're moving on to our next cumulative review and exam. So we'll spend more time reviewing for that since it's on 6 chapters instead of 4. Okay. All right, so the multiplication counting principle. The warm-up on here, I want to do part of this with you. Okay. So look at number 1 on the warm-up on page 21. I want to use this as an introduction to the notes. Okay, so it asks you here, how many ways can the letters A, B, C be arranged? Adam, we're in the notes, you know that, right? Page 21. Okay, so how many ways can we arrange letters A, B, C? So Donatus, what's one way we can arrange letters A, B, and C? Good, A, B, C. Mary, what's another way? Good, A, C, B. What's another way? Briar? Good, B, A, C. Sean, what's another way? Good. Zach, what's another way? Good. Charles, what's another way? Good. Emma H, what's another way? That's okay. Okay, Emma, you're stumped because we have them all. Trick question. Okay, we have them all. How many ways are there? Sorry, Emma. Doug, how many ways are there? Good. There's a total of 6 ways to arrange the letters A, B, and C. Now, this is annoying, right? Like to write all this out. Now, if I said to you, how many ways are there to arrange letters A, B, C, D, E, F, G? Like this is like flipping a quarter all class. You'd be writing out every single possibility for listing A, B, C, D, E, F, G. Okay, now that's annoying, right? Nope, there's many more than that. Can anyone see, I'll just ask now just in case, another way that we could have done that? Mary? Okay, not always, no. That's a coincidence, but I'm glad you're thinking. Jeremy? Okay. That's what Mary said, not always. Not always. Adam? Do you know what a factorial is?
Yeah.
Yeah, how'd you know that? Okay. Do you know why it works? Like, okay. Charles, but great job. Wow, I'm impressed. Okay, go ahead. I'm very impressed.
3 times 3 minus 1.
Yep.
So, the ABCD of
Oh, yeah, going all the way up. Okay. I don't want to say too much. Let me hold that thought because you guys are both right. Doug, do you want to add anything to this one? No. I'll tell you what it is. Hold on. Just not work. Thanks, Matt. It is 5,040. So A, B, C, D, E, F, G is 7, right? 7 letters. So you get 5,040 ways to arrange all those. So many more. I'm going to show you how I did it. Many more than 42. Okay? Anyone figure out how I got that? Fryer? Yep. And I'll tell you why. Charles? That's what a factorial is. So let me explain more, though, like the definition of it and what you actually need it for. Okay, 2 definitions first, then I want to have a conversation about factorial, but we're not going to get too far with it, but that's okay. So just real quick, since we did not write down the definition of tree diagram yesterday, that first definition on page 21 is tree diagram. Annalise, just hold that for a second. Okay. So even though we talked a lot about them yesterday, your book says a tree diagram is one way to count the number of possibilities. It uses branches to list choices. Now, do you not have a pencil? Adam. The tree diagram is my least favorite way. I don't know what you guys think, but I kind of get annoyed with having to draw all those branches when you have many other ways to solve for probability problems. So again, I don't think that's the best way to find how many outcomes there are or the chances of something happening, but it's an option. Okay, and that was more so of yesterday. Counting principle, we did a little bit yesterday, but more so today and tomorrow. So our counting principle is, it uses multiplication to find the number of ways 2 or more events can occur. So it always uses multiplication to find the number of ways 2 or more events can occur. And then after that, we're going to talk about factorial. Annalise? Okay, we're not doing that right now, but anytime it says number cube, there's always 6 sides. Yeah, I mean, the only time it wouldn't be is if it said we're rolling a 10-sided number cube. But
That's not cute.
correct, but that's what they say. So you'll see that, Donatus. Wait, what? Yeah, so what are you proving there? Oh, yeah, definitely. Way more than 42. Okay. I didn't know if you found another method you wanted to share with us. Yeah, you're exactly right. Way more. Okay, so here is what a factorial looks like. It does not mean you scream the number, okay? It doesn't mean you get really excited because you see a 3 and a factorial. It's not like English class, okay? So don't scream 3, okay? That's not, especially when you see it on a test. Okay, well, we're getting to that, Charles. I'm going to show you that. So, kind of like Adam yelled out, which I'm really glad he knew that, 3 factorial is the same thing as 3 times 2 times 1. Okay? Before I explain that further, let me show you where it is on your calculator. So if you have your calculator, open it up. Hold on, Doug. Okay. That's what we're using. Okay? If you have your graphing calculator, that's what we always need to be using. Type in the number 3. Okay? Okay, go to math, which is right here. So go to math. Hold on. Go over to PRB, hit the left arrow. Go to PRB. Number 4 is factorial. Right here, Emma. Did you hit the left arrow? Okay. Press number 4 and then hit enter, and it does it for you. So, well, because it's huge. Okay, listen. One more time. Listen. Let's try to give a 7. Everyone follow me. Okay, everyone type in 7. Stay with me. Go to math, which is right here. Go to the left to PRB. And then press number 4, because number 4 is the factorial button. Hit enter. That's how I got 5,040 so quickly. Annalise. Yes, I'm getting there. Charles. Yeah. The scientific notation gets a little crazy with some of these big numbers. Sean? Hey guys, I cannot hear Sean. Quiet. Yep, and I'm getting there. Okay, so shh, quiet, listen. Raise hands, Doug. Okay, yeah, that's huge. Okay, so I want you to write this down for the definition of factorial, and then we'll talk more about it. Okay, so a factorial is the product of integers from 1 to n, where n represents the number of objects. A factorial is the product of integers from 1 to n, where n represents the number of objects. Second part of the definition, it is used to determine the number of arrangements from a set number of objects. So I could use this when I make a new seating chart for you guys, and bless you, I could say, okay, if there's 15 of you in here, how many ways are there to arrange all 15 of you, given that I only have 15 desks? Now I'm changing it a little bit because technically I have 28 desks. Now that's a permutation versus a combination, which I'll talk about eventually. But if there were only 15 desks to put all of you in, okay, 15 factorial would be how I figure out how many ways there are to arrange all 15 of you in the 15 desks that I have. Now, that's a lot of ways. Charles, what did you get? Yeah, times 10, that's a huge number. So if I was trying to figure out all the ways, I would be here forever trying to figure that out. Because there's a lot of ways I could arrange you guys. Charles?
There are more, too, because we're not in a straight line.
Yeah, did you hear what I said, too? I also have more desks than the number of people that there are.
Even if we just had 15 desks, we're not all in a straight line.
That doesn't matter. That still calculates for all the possibilities. Doesn't matter if we're in a straight line or not. It still calculates for all of them. Okay, that's a good question. Everything does not have to be lined up perfectly. I could even use it for my bookshelves over there, and I could say if I have 25 pre-algebra books and I want to arrange all 25 of them over there, how many ways are there to arrange all 25 books? You would use 25 factorial. Okay, so I already had this example. You guys don't have to write this because we did one, but the book had another example. 4 factorial, you don't have to write that, is the same thing as 4 times 3 times 2 times 1. And then I also wrote down the calculator instructions in case you're worried you're going to forget it. Calculator instructions are math, PRB, and then number 4. So calculator instructions are math, PRB, and then you go to number 4. Charles? If you hit the calculus button, it just means calculator. It just means that's how you do it on the calculator. So math, and then PRB, and then number 4. So this part says, going back to the warm-up, which Adam knew, instead of listing all the ways ABC can be written out and arranged, all you do is 3 factorial, which is 3 times 2 times 1, much quicker, and you still get that there are 6 different ways to arrange all 3 of those letters. Okay, I'm going to do at least one example here, but questions on factorial at all? Charles? Yeah, that's just an interesting case. Annalise? Yeah, I mean, it's a little screen. You use scientific notation. Okay. All right, so let's do an example. Okay, example 1. You're buying new eyeglasses, okay, and you must choose the frame, material, and shape. The frame can be plastic or metal. The shape can be rectangular, oval, or cat's eyes, okay? To count, or round, thank you, or round. To count the number of possible choices for frames as described, make a tree diagram. So let's practice making a fun tree diagram. What should go at the top of our tree diagram? So what 2 words should go at the top? Matt? Nope. You want to be specific. Good. Plastic, metal. Okay, so there's our options for frames. What goes underneath each frame? Briar? Awesome. So I'm just going to abbreviate. Okay, how many possible outcomes are there, Doug? Good. So we get 8 possible outcomes by just counting on the tree diagram. Using the multiplication counting principle, what could you multiply? So using the multiplication counting principle, Annalise, what could we multiply? Good. So the multiplication counting principle says, take how many objects there are that we are arranging. In this case, it's 2 different types of frames and then 4 different shapes. That 2 times 4 is using the multiplication counting principle. You're just multiplying how many options there are. Now that only works if each type has the same amount of options. That whole card thing was weird because there were 6 red and 8 blue, whatever it was. Okay? It has to have the same amount of options. It has to be consistent here. So that 2 times 4 still gives you 8 possible outcomes. Okay, so you don't have to use the tree diagram. You can use this if you prefer. Sean? Correct. You only can use the factorial when you're trying to arrange objects. So that's the biggest thing of this lesson is factorials used to arrange objects. Tree diagram is to determine how many possible outcomes there are. Does that make sense?
Yeah,
Okay.
so just like multiplying or like adding or.
Yes. 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 We're going to do a lot more of that tomorrow. Annalise? Because there's 2 options for frames and there's 8 different shapes. So if you figure you have 2 options for something, the frames, once you pick that, you have 4 other options. It's very hard for me to explain, but drawing it out is the same thing as multiplying 2 times 4. It just always works. And that's kind of like you probably use common sense sometimes on things like that and don't even realize you're using the multiplication counting principle. Doug? Hold that thought, okay? What are you on right now? Okay, hold that thought. Adam? Yeah. Hold on. It depends if we care if order matters or not. Do you care about the order?
Yes.
No, it would have to be this. It'd be 20. If you cared about the order, you have to use a permutation. So it'd be 28 factorial over 28 minus 15 factorial. It's always n factorial over n minus r factorial. You're ahead of me. I'm getting to that. So if the order mattered, you would do this. If the order didn't matter, you would do this. Hold on. So if the order didn't matter, it'd be 28 factorial over 28 minus 15, that's a minus, minus 15 factorial times 15 factorial. Okay? You probably did, but I'm getting to that eventually. All right, homework time, because I don't have time to keep going. I wish I did. Okay, homework's going to be short tonight. So I want you to open up your homework packet to page 92. So page 92, hold on, numbers 1 to 5, and yeah, there's an and practice 6.8. Numbers 1 to 5 as well. Okay, that's all. Do not go further because there are things I still have to teach you tomorrow. Okay, even if you think you know what you're doing, I don't want you to mess up and be confused. Tomorrow we'll finish up factorials. So page 92 in the homework packet, 1 to 5, and then practice 6.8, 1 to 5 as well. Sean? Yeah, we're getting there. That's tomorrow. Yes, but we're getting to that tomorrow. All right, time to go. I'm a little behind here. Doug, you can come on up if you have a question.